Right, this is the second part, chapter 3, polynomial functions, review for the semester 1 final for Algebra 2. Okay, so standard form, write the equation, the polynomial in standard form. We want to write the highest exponent first. So the highest exponent is going to be 7x to the 8th, plus the next highest is 9x to the 7th, plus 4x to the 3rd, plus 5x squared, plus 3x, and then minus 2. That would be standard form. You're going from largest exponent descending to smallest. All right, number 2 is classifying polynomials here. Okay, so let's see a first degree. What do we have? First degree, second, third, fourth, and fifth. Okay, and then we're going to have terms. We're going to have one term, two terms, three terms, and then 4 plus, 4 or more terms. Okay, if it is a first degree polynomial, we call that linear. If it's second degree, we call it a quadratic. If it's third degree, we call it cubic. If it's fourth degree, we call it quartic. If it's fifth degree, we call it quintic. Quintic. Okay, if there's one term, we call it a monomial. If there's two terms, we call it a binomial. Bi meaning two. If it's three terms, we call it trinomial, tri meaning three. And then if it's four or more, we're going to say it's a polynomial with x terms, right? With 4 terms or with 5 terms or something like that. Okay, so for the first one, highest degree is 2. So it's a quadratic and it has 3 terms, 1, 2, 3. So this is a quadratic trinomial. Quadratic because it's the power of 2, second degree. Trinomial because there's 3 terms, 1, 2, 3. Okay, the next one is a quintic, a polynomial with 4 terms. Okay, it's quintic because it's degree 5 and it's got 4 terms, 1, 2, 3, 4. So if it's 4 or more, we have to say quintic polynomial with 4 terms. Okay, this one is a cubic monomial. Cubic because it's degree 3, monomial because there's just 1 term. Okay, and then this one is linear binomial. Linear because it's x to the power of 1. Binomial because there are 2 terms. Okay, good. Let's go to number 3. Okay, end behavior. Okay, end behavior. Let me draw some graphs here for us. Let me draw 4 of them. Okay, the degree could be even. So let's put degree over here. And then let's put leading coefficient. Coefficient. Only one E here. Okay, so if our degree is even and our leading coefficient is positive, it's going to look like this. Something like this. If the degree is even, but the leading coefficient is negative, it's going to look something like this, right? They're going to go in the same direction the end behavior is, but it's going to be going down instead of up. Okay, if the degree is odd and the leading coefficient is positive, it's going to look something like this. If it's odd and negative, it's going to be flipped. It's going to look something like this. Okay, so even, it's going to go in the same direction. Odd, they're going in different directions. Positive, they're both going up. Negative, they're both going down. Odd, you're increasing. Negative, you are decreasing the whole at the ends. Okay, this is degree 3. Okay, third degree, so it's odd. And then the leading coefficient's -2, so it's negative. So our end behavior is going to look like this. So how we're going to write that, okay, if I can undo the circle, is going to be as x goes to infinity, right? So as we go to the right, we are going down. So as we go to the right, y is going to -infinity. Okay, as we go left, so as x goes to -infinity, as we go left to -infinity, y is going up to +infinity. So this is what my end behavior answer should be. As you go right, you go down. As you go left, you go up. So as we go right to infinity, we go down to -infinity. As we go left to -infinity, we go up to +infinity. This would be my answer. Okay. All right, the next one. Let's scoot this over. Okay, let's delete this. Okay, this one, let's see. We have 6th degree, so it's even, and then positive, so it's going to look like this. Okay, so let's write our end behavior. So as x goes to infinity, meaning as we go to the right, y is going to increase to positive, right? We're going to go up. As you go right, we're going up. As you go left to -infinity, as you go left to -infinity, we are also going up to +infinity. Okay, so as we go right, we go up. As we go left, we also go up. So there's our answer. That's our end behavior. All right, let's look at number 5 and 6. This is going to be adding and subtracting polynomials. Okay, so remember, if there's that 1 in front of it, we don't need to write it, the parentheses, right? Because you're really just distributing a 1. So it's really just 2x to the third plus 3x squared plus 4 plus, and then 6x to the third minus x squared minus 5x. Right? So when you're adding, you're basically just getting rid of the parentheses. You don't need to worry about them. Okay, the only thing left to do is combine like terms. So that's going to be 8x to the third plus 2x squared minus 5x, and then plus 4. Pretty straightforward there. Okay, number 6 is subtracting. So the big thing is when you subtract, you got to make sure you change the signs. You got to distribute the -1. Okay, so for the first one, it's going to stay the same because we're just distributing a +1, right? So it's 5y to the fourth plus 5y to the third minus 6y squared plus 14. But then over here, you got to make sure you distribute the negative to each term. So it's going to be plus y to the fourth minus y squared plus 7y, and then plus 1. Combine like terms, we have 6y to the fourth plus 5y to the third minus 7y squared plus 7y, and then we have 15. And there's my answer. Okay, 7 and 8 are multiplication. So we're going to multiply polynomials now. Okay, so let's multiply. We got to distribute, right? And then do this as well. So 3 times 2x is going to give me 6x to the third minus 15x plus 21. I'm sorry, minus 15x squared plus 21x minus 8x squared plus 20x and then minus 28. Combine like terms, we got 6x to the third. Minus 23x squared plus 41x. And then minus 28. Okay, and there's our answer. There's our solution. Hey, number 8. Multiplying here. So again, 2x squared times 4x squared is going to be 8x to the fourth. 8x to the fourth. Minus 10x to the third. Minus 6x squared. Minus 28x squared. Plus 35x. Plus 21. We just got to combine like terms. All we can combine are the two in the middle here. So you have 8x to the fourth minus 10x to the third minus 34x squared plus 35x plus 21. And there is my solution. All right, flip it over. We got number 9 and 10, which is division. Okay, so we're going to use long division for the first one and then synthetic division for the second one. So I'm going to do 2x minus 6. I need to divide that into 2x to the fourth plus 0x to the third minus 6x squared plus 3. I'm sorry, plus 0x plus 3. So again, we're missing a plus 0x squared here, and we're missing a plus 0x. So I'm going to keep them in mind as placeholders, right? Because sometimes you can screw up if you don't keep your placeholders in there. You can do it without them, but I would add in, strongly recommend adding in 0x to the third and 0x, okay, for placeholders. Okay, 2x times, so we need something. We know how many times does 2x go into 2x to the fourth. One way you could do this is divide them. Okay, if we divide them, 2's cancel, x to the fourth is going to give me x to the third, right? So I know x to the third times 2x is going to give me 2x to the fourth. And then x to the third times negative 6 is going to give me negative 6x to the third. Okay, and that's why we want to have 0x to the third, so we have a placeholder. Okay, we're subtracting, so we need to switch the signs. So this becomes negative, this becomes positive, that cancels. So we're left with 6x to the third minus 6x squared plus 0x plus 3. Right, plus, so again, if you don't know what to do, we can divide it. So 6x to the third divided by 2x is going to give me, that's going to be a 1 to a 3. And then you're going to be left with x squared, right? Because x to the third divided by x is x squared. So it's going to be plus 3x squared. 3x squared times 2x is going to give me 6x to the third. 3x squared times negative 6 is going to give me negative 18x squared. We're subtracting, so we need to flip the signs. So that cancels. And we're left with 12x squared plus 0x plus 3. All right, again, 12x squared, I would just divide it by 2x. Okay, so that's going to give me 6x. All right, this cancels to a 6 and a 1. And then x squared divided by x is just x, so it's going to be plus 6x. So 6x times 2x is going to give me 12x squared minus 36x. We're subtracting, so we need to switch the signs. We're left with 36x plus 3. This is going to be 18, right? So 36x divided by 2x is going to give me 18. So I'm going to do plus 18. 18 times 2x is 36x. 18 times negative 6 is 100 and negative 108. Okay, we're subtracting, so we need to switch the signs. And that gives me 111 as my remainder. So I need to put plus 11 over 2x minus 6. And that's going to give me my solution. Okay, so a remainder of 11, so it's plus 11 over 2x minus 6. Okay, that's long division. Now let's do synthetic division. So synthetic division. So I want to use my 0. So x plus 2 equals 0, which means my 0 is negative 2. So I'm going to use negative 2. Okay, and then I have 1, 2, negative 3. I should have plus 0x squared here. So it's going to be a 0, and then a 1, and a negative 1. Because this is really a 1x, right? Okay, we're going to bring down our 1. Negative 2 times 1 is negative 2. Negative 2 times 0 is 0. Negative 2 times negative 3 is 6. Negative 12. And then that's negative 11. And that's going to be positive 22, which is going to give us a remainder of 21. Okay, it's x to the 5th, so we're going to drop it down to x to the 4th plus 0x to the 3rd minus 3x squared plus 6x minus 11 plus 21 over x plus 2. Okay, I don't need to write the 0x to the 3rd, so I'm actually going to erase that and just leave it as x to the 4th. Okay. There's synthetic division. All right, 11 and 12 here. Okay, so find the zeros of the polynomials. So we want to know when the value of y is 0. This is already factored for us, so all we have to do is set each factor equal to 0 and solve. Okay, so x equals 0, x minus 7 equals 0, and then x plus 4 equals 0. So I got x is already equal to 0. This one I can do plus 7, I get x equals 7. I can do minus 4, and I get x equals negative 4. So my three zeros are going to be 0, 7, and negative 4. Okay, over here, again, we want the function to be equal to 0. So I need to do 4x equals 0, 2x minus 7 equals 0, and then x plus 2 equals 0. So if I divide both sides by 4, I get x equals 0 divided by 4 is 0. This one I can add 7 to both sides, and then divide by 2. So I get x equals 7 over 2, which is 3.5. Okay, subtract 2, we get x equals negative 2. Okay, so my three zeros are 0, 7 over 2, and negative 2. All right, 13 and 14, find the zeros of the function and what are their multiplicities? So we need to factor here. So I'm going to do y equals, I'm going to factor out an x. So I'm left with x squared plus x minus 6. Okay, I can just use the x method here. I need two numbers that multiply to -6 and add to +1. That's going to be +3 and -2. So I get y equals x, and then you have x plus 3, x minus 2. Okay, to solve for the zeros, we need the x value when y equals 0. So we just need one of these terms to be 0, one of these factors to equal 0. So I'm going to do x equals 0, x plus 3 equals 0, and x minus 2 equals 0. So x equals 0 is good. I'm going to get x equals -3 when I solve. And then x equals +2. Okay. If we look at our function here, this is x to the first power. This is x plus 3 to the first power, and x plus 1, x minus 2 to the first power. So the multiplicity is odd, right? 1 is odd. Okay, the multiplicity here is odd. And the multiplicity here is odd, right? Because we have a multiplicity of 1. Let's just write it out. Okay, we're going to say they all have a multiplicity of 1. All the zeros have a multiplicity of 1. Okay, the multiplicity is how many times the 0 occurs. Each of them occurs 1 time. Okay. 14. Same question. We can factor out x squared. We're left with x squared minus 8x plus 16. We can use our x method. We need two numbers that multiply to +16, add to -8. That's going to be -4 and -4. So you get x squared and then x minus 4. X minus 4. All right, so that's the same as writing it as x squared and then x minus 4 squared. Okay, so in this case, we're going to get x equals 0 and x equals 4. And the multiplicity of each of them is going to be 2. So the multiplicity is even. It's 2 because it occurs 2 times. It's x squared. X minus 4, the multiplicity is also 2. Okay, so if we were graphing this, right, they're both going to bounce, right? They're not going to go through the x-axis. They're going to bounce at 0 and bounce at 4. Okay, and that does it for the second part of the review for the semester 1 final, topic 3.